NCERT Physics Class 11th, 5th chapter, which is laws of motion, question number 5.14. So in this, we have to define what is the net force acting on the particle for t less than 0, t greater than 4, and t between 0 to 4. So we can say from the graph that t less than 0, for t less than 0, the position of the particle is not changing, the position of particle is fixed. So particle remain at rest in an interval. So whenever the particle remains at rest in an interval, we can say that acceleration of the particles would be 0. So in first case, acceleration is 0 as particle remain at rest in an interval. If particle at rest at an instant, then acceleration may not be 0, but whenever particle remains at rest in a particular interval, for interval of time the particle remain at rest, then in that case acceleration must be 0. Moving to B part, from B part t less than 0, t less than 4 greater than 0 second. So for second part it is asking about this region. So in this region we can say that velocity is equal to dx by dt, and dx by dt is slope of xt graph, which is straight line, and slope of this graph is constant, so velocity is constant, and if velocity constant, this implies acceleration of the particle is 0. C part, so in C part we can again see that the position of the particle remain fixed. Position of particle is not changing, so particle is at rest, and if particle is at rest in an interval, then acceleration of particle would be 0. Coming to B part, sorry, this is different section of part, this was different section of part A. These are not ABC, this is first part of A, this is second part of A, and this is third part of A. Now moving to part B. Part B is saying that we are supposed to find out the impulse as t equal to 0 and impulse at t equal to 4 seconds. Now what is impulse? Impulse is represented by symbol j, and it is change in linear momentum. Impulse is equal to change in linear momentum, that is equal to m into v minus m into u, where v represent final velocity and u represent initial velocity. Now I'm coming to first at t equal to 0. So in order to talk about t equal to 0 second, we can say that impulse is defined for very short interval. So just before t equal to 0 and just after t equal to 0, the velocity changes from 0 to this velocity v, and this velocity v is equal to dx by dt, that is equal to slope is equal to tan theta, and the value of tan theta can be easily find out. Let's say this angle is theta, so tan theta can be given by 3 by 4. So just before t equal to 0 the velocity is 0, and just after t equal to 0 the velocity is 3 by 4. So change in momentum can be given as, if mass of particle is 4 kg, then change in momentum can be given as 4 common aa gaya, and final velocity is 3 by 4 and initial velocity is 0, so change in momentum that is equal to 3. So impulse is equal to 3 kg meter per second. Now in second part we are supposed to find impulse at t equal to 4 second. So in order to find impulse at t equal to 4 second, so again impulse is defined as change in momentum. So this is m, final momentum that is v dash, and initial momentum that is u dash. M is common. So we have to find final velocity and initial velocity at t equal to 4 second. So if we look at t equal to 4 second, so just after 4 second velocity is 0, and just before 4 second the velocity is 3 by 4. So change in velocity, after change in momentum is given as v dash, this is 0, and initial velocity, this is 3 by 4. Putting the value of mass as 4 kg, this change in momentum can be given as minus of 3 kg meter per second. So at t equal to 0, the momentum is 3, the impulse that is change in momentum is 3 kg meter per second, and at t equal to 4 second, the impulse which is change in momentum is minus 3 kg meter per second.